Hello friends, welcome to SS tutorial. Today we will discuss about work, power and energy. First we discuss about work. What is work? Work is said to be done only when the force applied on a body makes the body moves. Just look below figure. The man is trying to pushing the car, but the car does not move. Then according to science, we can say there is zero work. When the car starts moving by the application of the force, then we can say the person is doing work, or science will say work is done. Similarly, when the person stops, when the car stops moving, then again it will be zero work. How we measure the work? Look at the below figure. The person pushing the car by applying a force F. By application of this force, the car moves a distance S. So the work done is equal to the applied force into displacement of the point of application of the force in the direction of force. So your W is equal to F into S. Unit of work, its SI unit is Joule and Sousa's unit is Arch. Relation between Joule and Arch. 1 Joule is equal to 1 Newton and meter. 1 Newton is equal to 10 to the power 5 dyne, and 1 meter is equal to 10 to the power 2 centimeter. So 10 to the power 5 into 10 to the power 2 is equal to 10 to the power 7 dyne into centimeter, which is equal to 10 to the power 7 arch. It means our 1 Joule is equal to 10 to the power 7 arch. Work done when the displacement is not in the direction of force. Just we discuss about the work done. Just we discuss in our previous slide. It is about the motion in a straight line. The point of application of force, the direction of the force and the direction of the motion are in the same. Both are in the same direction. Now we discuss when the displacement is not in the direction of the force. We can calculate by two ways. One, by finding the component of displacement along the force, and second method is by finding the component of force along the displacement. First we discuss finding the component of displacement along the force. Just look at the figure. Here a vehicle trying to climb a inclined plane. Just my inclined plane is, I just draw it to ABC triangle, and which makes theta angle to the ground, and my displacement of the vehicle from A to C is S, and the force applied to the vehicle is F. Now how can we calculate? To calculate our work done, we have to find out, first we find out the component of the displacement along the force. The direction of the force is from right to left. Just look at here, the direction of the force is given, so we have to find out the displacement along the direction of the force. So the displacement is AB. We have to find out, because AB is the distance it covered, but we have to find out the displacement. The displacement is A to B. So we have to find out the AB displacement. To find out AB distance, we have to consider the triangle ABC, in which in the triangle ABC, cos theta is equal to AB by AC. That is the base by hypotenuse. So we can write it AB by S, because our AC is equal to displacement is equal to S. Now your AB is equal to S cos theta. Okay. So we can say the work done is equal to F into AB. So F into S cos theta, which is equal to Fs cos theta. Similarly, we can find, well, we calculate the work done by finding the component of force along the displacement. I just consider the same figure, but Here I just change, rather than finding the uh, displacement in the direction of the force, I just calculate the force along the direction of the displacement. Look at here. Just I applied the force at here. PA is the force applied to the vehicle, and AC is the displacement. If I take the displacement S, that is along the AC, so I have to find out the force applied through NA, not FPA. I applied the PA, which is but horizontal to the ground. But here we have to find out along that direction of the displacement, the force applied along the direction of the displacement. That is, the force is AN. AN force is applied. So to calculate the AN, we have to consider the PNA triangle. In PNA triangle, PNA is the 90-degree and PAN is theta angle. So we have to find out here cos theta is equal to AN by AP. So we can write down here AN by F, because your AP is equal to F, force applied. So AN is equal to F cos theta. Now you can calculate the work done. So work done is equal to force applied along the direction of the displacement. So force applied along the direction of the displacement, that is F cos theta, into F displacement is S. So our work done is equal to Fs cos theta. Okay. This is the two methods by which we can calculate the work done if the displacement is in some inclined plane, or if the displacement makes some angle in the direction of the action of the force. Just to discuss some special cases. If the displacement in the direction of force, what we'll do? Just look at here. It is a just tree. A fruit fall from the tree to the ground like this. Here, my displacement is towards downward, as well as the gravitational force is also downward. So the angle between the displacement and the gravitational force, that is 0°. So according to our formula, work done is equal to Fs cos theta. So W is equal to Fs cos 0°. But the value of cos 0° is 1. So our work done is equal to F into S. So if our displacement in the direction of the force, then our work done is just the multiplication of force and displacement. If the displacement perpendicular to the direction, what we'll do? Just look at here. The man carrying a load walking straight. Now the force applied to the load is vertical, upward, and the displacement is the horizontal. So the angle between the force applied on the luggage and the displacement, that is 90°. So here theta is equal to 90°. So W is equal to Fs cos theta, and work done is equal to Fs cos 90°, which is equal to Fs cos, value of cos 90 is 0. So work done is here 0. So if the displacement perpendicular to the direction of force, then the work done is 0. Here the person carrying a load walking through the distance, walking some distance, then the work done is said to be 0, because the force applied to the load is perpendicular to the upward and the displacement is just forward. So angle between force and displacement is 90°, hence the work done is 0. This is called 0 work. Similarly, if any object moving in a circular path, then it also be 0 work done, because the direction of the motion, in our previous class I discussed about the circular motion, the direction of the motion always tangent to the centripetal force. It means the centripetal force in the direction of the motion is a 90°. So the total work done is calculated to be 0. If the motion against the force, opposite to the force, just if the displacement opposite to the direction of force, just look at the figure. The boy is just throwing the ball towards the upward, hence The direction of the displacement and the gravitational force both are in opposite direction. Hence here, so here theta is equal to 180 degree. So our work done is equal to force applied into distance covered into cos theta. So Fs cos theta. So Fs cos 180 degree. The value of cos 180 is -1. So it is minus Fs. So work done if the motion is just opposite to the force, if the displacement is just opposite to the force, then work done is called as the negative work. So it is called negative work. Now we discuss about the power. Is power. The rate of doing work is called power. Just look at here. A bus and a motorbike. Both are given a target to cross the red line. They start at a same point, but the bus reached just in 2 seconds, but the bike take it 3 seconds. So just look at here. The bus reached at here 2 seconds and the bike reached within 3 seconds. It means both of them done the same work, but the power of bus is more than to the bike. So it reached earlier than the bike. So how can we calculate the power? The bus takes 2 seconds to cross the target line, while the bike takes 3 seconds to cross the target line. The work done by both is same, but the power spent by the bus is more than the bike. So our power is always equal to work done by time. What is the unit of power? Its SI unit is watt and Celsius unit is Och per second inverse. Now we discuss about the energy. What is energy? The energy of a body is its capacity to do work. Just look at here. In the given figure, that the girl lifts 10 kg while the boy lifts 30 kg. It means the boy has more energy than the girl. Unit of energy. SI unit of energy is Joule and Celsius unit is Och. This is some questions for you. I think you will do it. If you find some problem in solving this question, just reply me or comment me in comment section of my YouTube channel, so I will help you. Thank you for watching.